Grüezi miteinander. Yeah, see, that's how I thought that everybody was paying attention. My German is terrible. My Swiss German is even worse. So I'm going to continue with my terrible, terrible English, unless anyone here in the audience would like to speak Spanish with me. Exactly, perfect. So remember that to ask your questions using a Slido, or if you, you can do this anonymously, or you can also raise your hand any point in time. We have about 45 minutes, and I hope that you have had a good time at JCON. Who's here for the first time at JCON? Wow, half of the room. This is amazing. I hope that you have had a good time so far. This is sadly the last day. And if you miss any content prior, there's going to be recordings for all the things, so you can watch the content later. All right, so today I have for you setting up data-driven test cases with Java tools, and I will expect that most of you are Java developers, I guess. Anyone here doing JavaScript? Yeah, brave, good. So this is the agenda that I have for you today. Where are we in terms of doing test cases that are somehow related to the database? I'm going to showcase a handful of testing tools, database software, how we can put things together. It's going to be a light demo, and there's going to be fire and smoke, and then closing remarks and resources. Okay, so I'm going to tell you about a little bit story that happened to me about 15, 20 odd years when I was still a consultant, and hopefully, or maybe, I don't know if someone will identify with this kind of story. So here I was in charge of a legacy project where the database was quite old, and it was hosted on a small machine and on a small computer that no one wanted to touch, hidden somewhere at the back of the server room. No one was allowed into it in order to upgrade it. So that was kind of the problem. I needed to add new features to the software. I could not go into the machine, log in properly with the administration rights, and set up the right versions and do the upgrades, and it was terrible. So I needed a way to test out this new version of the program in a local environment with something that could match the same database capabilities, and somehow with access to real production data or not. So this was my issue. My issue was trying to provision the same environment or very similar to production. So back in the day, the options were that if you are lucky to be able to download the given version and install it on a local environment, that's great. But that will only work for you. If you were working on a team, you had to share that instance. So the problem now comes in is who is going to test what and when? Because if two or more people are testing against the same database as a shared resource, then the test cases will likely fail because the data is not in the right state when someone wants to run it. And when you compound in CI/CD servers, then CI/CD server becomes yet another teammate for which you need to share that particular resource. So provisioning was quite hard. I literally had to call the IT guy, say, hey, can you provision such and such version of the database? And 3 months later, he will tell me, it's done with the wrong version number, but at least I kind of got something. Yeah, does this ring a bell for someone of you? Okay, I'm glad that I'm not seeing any hands, or you're too shy for this. So provisioning MySQL and Postgres, even back in the day, was kind of straightforward. Just download a zip, configure your path, and off you go. For the other databases, that wasn't the case. And then, of course, we got Docker. And Docker kind of like make things much, much simpler. Yet, there are still some issues with some databases. And now that if you combine in running CI/CD pipelines, then setting up the right version, the right settings, the right configuration, at the moment that you need it, with the right state, yeah, things start to get much more complicated. So obviously we had questions how we can sort this out. But it's not just the matter of setting up a given database instance. You also need to set up the database state, the database data, the initial schema, run all your test cases, and then do the validations. If we were to do validations well, that's ahead of myself. If we do the validations using the application code, well, we're kind of like fooling ourselves because we want to test the application code. So we go one level down into the framework, whether this is a Spring Data, Micronaut Data, Hibernate, JPA, you name it. yeah, that can certainly work. But if there were to be any issues with those implementations, then we have to wait for the next release in order for our test cases to be successful. So what if we were able to go one level down closer to the database? And so that's the thing. And if we were to write our own code to use plain and simple SQL statements to do these verifications, we might also get into trouble if we wrote wrong our queries. So we need something that is more robust than that. So that was me some years ago trying to figure out all these answers, all these questions. And luckily for me, there is a bunch of test libraries and unit-based frameworks that we can use to solve these issues. So in terms of testing tools, the first one is Testcontainers. Who has not heard about Testcontainers? Just a few hands. Okay, this I like, because that means that most of you are now having a much better development experience, right? Am I correct? Because for those of you that have no clue of what Testcontainers is, this is one of those technologies that when it comes into your developer life, you adopt it because they change your life for the better. Does anybody else agree? Yeah? Right. So what does Testcontainers do? They basically allow you to run any kind of software that is capable to run inside a container, and you connect your test cases to that database or to that particular container. So say that if I wanted to provision a Kafka cluster or RabbitMQ, what do I need to do? First, I need to download the particular version that I want to, and then install it on the given server, whether it's my local environment or it's a CI server, and then start it, configure it, wait for the service to be up, connect to it, and then run my test cases, right? So if I do all these things in a manual series of steps, it's going to take first forever. It will be error prone. And then if I need to replicate this on CI, how I'm going to automate all these things? This is one of the things that Testcontainer does for us because it eliminates most of the manual steps and all these boring configurations by providing ready-made containers, or in this case, it's modules that allow you to talk to many different things like, again, Kafka, MySQL, Postgres, Oracle, what have you. It started as a Java project, but you can use it with different languages. So there's a list of all the different languages right there. So the second one that is the most common one, I think, is Go, and then it is JavaScript. And they have a list of modules that allow you to talk to many different containers, so a specific software that you may want to use. They automatically manage the configuration of these containers. They also manage the lifecycle, because one thing is to say, I want to start a container for any particular software, run all your test cases, and then someone has to take care of destroying the container regardless of if your test case was green or it was red. So those resources have to be reclaimed again. So that's what Testcontainer does. It takes care of that. But obviously, we're talking about Java. And there are tools that we can use in conjunction with Testcontainers. Because the two problems that I mentioned before, one was provisioning, and the second one was asserting the state of the database before and after. So Testcontainers takes care of provisioning. But how are we going to supply the initial data to the database, and how are we going to verify that state? Let's see some hands here. Who uses Spring technologies? So most of the room. Anyone here uses Quarkus? A few hands. Micronaut? Less hands. Helidon? Any other Jakarta EE implementations? Also a few hands. Well, the good thing is that it doesn't matter which one you use. All of them have some sort of integration with Testcontainers. Whether it's like a Spring Boot and Quarkus, they have something known as depth services. They will automatically look into your configuration and can create containers whenever you want to test. So you don't have to explicitly say, I want this particular container. This just happens by magic. This is why we use these frameworks. It's all black magic. Whereas the other frameworks are a bit more explicit. But regardless of that, you can still use them together with Testcontainers. So JUnit 5, does anyone know how old JUnit 5 is? Okay, let's see. 2 years, obviously no. 5 years? 7 years? 10 years? Yes, it is 10 years old. And it doesn't feel like that. But this is the version of JUnit that gave us modern capabilities like, hey, finally we can use lambdas. Anyone here still using JUnit 4? Yeah, a few hands. Okay, don't worry. There are ways for you to still make use of these things that I'm going to showcase today. So obviously, JUnit 5 is kind of like the de facto standard. It's actually the most downloaded library from Maven Central, which is pretty good. Now, for asserting the state and setting up the initial state for a database, back in the day, I discovered this project called DbUnit. This started back in the day with JUnit 3, if I'm not mistaken. And development is still ongoing. It's a little bit slow, and it only works up to JUnit 4 in terms of the API compatibility. You can use it certainly with JUnit 5, but it does not provide compatibility or integrations with the latest features of JUnit 5. For example, in the past, we used to have something that if you want to to run a test case connected to the database, you had to extend from a base data test case. Later, you could use something known as a rule, which is the extensions in JUnit 4. But we have a proper and different extension mechanism in JUnit 5, which is not provided by this particular framework or library. But we still can make a use of that. If you happen to see a QR code on the screen, that is a quick, that's the URL for the particular project I'm talking about. So, given that we were talking about JUnit 5, what we can do in order to consume or to use newer features of Java and also talking to databases. There is another project called DB Rider or Database Rider. Happens to be an extension to DbUnit. That's how it was born. So an extension to an extension. This is the one that gives DbUnit the capabilities to also run in JUnit 5 natively and gives you modern access to Java constructs. There's a bunch of annotations. There's a lot of things that you can do with DB Rider. So if you want to run test cases that are connected to the database, my suggestion will be first have a look at DB Rider. And if for some reason this does not work for you, then you go into DbUnit, which is what is the powerhouse behind this one. Okay. So when it comes to database, Testcontainers, DbUnit, and Database Rider will be able to talk to pretty much any relational database. The other thing that I like about using these tools together is that in the past, because we had issues provisioning a database, they say I cannot use my production database by SQL Server or Oracle or DB2. In order to accelerate my development, I will use an in-memory database. Because why not? Anyone here use H2 or HSQLDB? Yeah. As long as we stay to the SQL standard, then nothing should work wrong. But the moment that we're using something that is specific to that, but RDBM's vendor, then we will not be able to test fully all the capabilities. We will need the actual server. So this is the reason why I propose to use Testcontainers. Because instead of relying on an in-memory database that may or may not be fully compatible with your use cases, you can use the real server. Now, who here has had the pleasure of installing an Oracle database? Did you like that procedure? No, right? It was so-so. But who had here installed MySQL or Postgres? And was it quick? Nice? Yeah? And you could do this, you could run this also on containers very easily, isn't it? Would it be great if we could do the same thing for the Oracle database? Given that the Oracle database is pretty much everywhere out there, you are either migrated into the Oracle database, or some of you might be thinking, oh, let's migrate away from the Oracle database because it's a hassle, or so many other reasons. Well, let me tell you just very quickly that there are alternatives to that. So we're going to talk about MySQL, Postgres, and the Oracle database. The first two, they are very easy to get to. You can install them directly, download in a zip file or a tar file. You can use it on Docker. It starts very, very quickly. Configuration is simple. This is one of the reasons why people prefer to go with these databases. You get it started very, very quickly. You just go. Whereas with the Oracle database, well, not really. Or is it? Because it so happens that the Oracle database, just like other vendors, they have this feature called multi-model that allows you to have multiple different data formats inside the same database engine. So for example, Postgres has pgvector, so you can have vector databases, and it also supports JSON. MySQL does the same, but Oracle supports pretty much all the different formats, including vectors right there. Now, there is a cloud version that you can get for free. You just have to sign up to the Oracle Cloud for free, and we're not going to charge anything for you. And if you cannot use the cloud version for whatever reason, there is another version that you can download on your machines. It works on Linux, on Windows, and Mac, and it also works on Intel, on ARM architectures. So pretty much on this machine, no problem whatsoever. And you can run it on development, testing, and production for free, as long as the quotas will fit into use cases. For in this case, you can only address up to 2 gigabytes of RAM and 12 gigabytes of storage. If your use case fits within those limits, you go crazy with it. There's, of course, you can run it on Docker. There are official images for this this version of the software, except that the official images are a little bit heavy. They take 9 gigabytes to download and 3 minutes to start. Does anybody have the time to wait 3 minutes for every time you want to run a test case against an Oracle database? Not really, right? So what if I tell you there are alternatives to this, such as this one, that allows you to download just 900 megabytes, is layer, and it starts in 10 seconds. This is from version 23, which is the latest version, 23 AI and onward. And there is another URL for those that need to run Oracle database from 11 to 21. These are the images that Spring Boot and Spring Technologies, Quarkus, Vertex, Hibernate, every other open source project that supplies or provides integration with Oracle technologies, they consume these images, and they use it via test containers as well. So if it's good enough for them, which are the ones that produce the base software that you consume to create your own applications, I hope that is also good for you as well to build your own test cases. You might also be thinking, that name over there doesn't say really Oracle. It's not an Oracle organization. It's some guy whose name is actually Gerald Wenzel. Is this some random guy from the internet that's going to hack you if you happen to use these images? Fear not. That guy is my manager. He works for Oracle. So we decide to push the advantages on these new capabilities to make the images faster and quicker in the open. So you can see actually these Git repositories contain the scripts on how these images are created, so you can tell what is going on inside the images, such that you will be able to consume them much, much easily. It's our hopes that everything that we have done to make these images work better will eventually be merged into the official images. So we're going back to test containers. You can have modules for all kind of software. So there is MySQL, there's Postgres, there's InfluxDB, and there are 2 modules for Oracle. One for Oracle Free, that's version 23 onwards, and there's Oracle XE for 11 to 21. So you choose whichever module you want, depending on the database that you want to talk to. You configure that in your Maven spawn file or your Grail build file. It's just one dependency. And then you have access to explicit container that knows how to talk to that software. So there will be a Postgres container, like an Oracle container, Kafka, RabbitMQ, all those things. And the only thing that you have to do is provide the name of the image that you want to consume with that particular container. Every other specific property for that container should be handled by the model. If there were not to be a module for a given piece of software, maybe there's something new that's coming out there that everybody wants to use, but there's not yet a module, a test containers module, then you have to use a generic container and set up all the explicit properties that are required for this particular piece of software. So this is the reason why we have service or software-specific modules, so that your configuration becomes much simpler. All right. In case that you didn't know, you can also download the Oracle drivers from Maven Central. This happens in September 2019. In the past, people used to download them from a page from Oracle Technology Network. You had to agree on the license and click on a checkbox, download this, and put it in your artifact repository, blah, 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 blah. That thing is in the past. Now you can download these drivers just like you would do with MySQL and Postgres, and you don't have to tick on that checkbox for the license because we have a newer license that allows you to do anything you want to. It's very permissive, so just go crazy by using the software. If you need to use a different set of drivers or different jars to connect to different versions of the Oracle database, so on-premise and on cloud, then this URL will tell you the list of all the different artifacts that are available, the reasons why you would like to use different artifacts, and how you can combine them with both Maven and Gradle. All right, it's time for the demo. Enough of this of the theory. I have a very trivial Spring Boot application, and by very trivial, let me show you the contents of my beautiful application, which is empty. Because I don't care about what the application is doing. What I care is to showcase how you can use it alongside Spring data. And if for those of you that use Quarkus or Micronaut or the others, the thing that I like about these different frameworks is that even though the names of the annotations and some of the base classes may be different or may be similar, the concepts are quite the same. So if today you're using the Spring technologies and tomorrow you move to another team or another organization that happens to use Quarkus, then your knowledge is transferable from one environment to another. You don't have to start from scratch. So for most of you, what I'm going to showcase will be very familiar. If you're not familiar with Spring Boot, then some things will definitely click and fall into place. So I have an entity, which is quite simple. It's just customer with 3 properties and an ID. And I have a repository that will allow me to do all the CRUD operations that I want, so all the basic ones. Plus, I have defined 2 custom finders. All right. So I want to test out these things. I want to test out the basic constructs from Spring Data, because there might be a hidden bug in the implementation of the chosen version of Spring Data. But I also want to be able to insert or to delete or to do anything else that I want with customers and the database. I think that in case of the POM configuration, let me show you the dependencies that we have. There is what version of the Spring Boot? It's not the latest version of a Spring Boot. We have changed the version number for the Oracle driver, because one of the things that the Spring does is manage versions for many dependencies. And one of them happens to be the Oracle driver, which the default for this version of a Spring Boot is kind of like 23.5, I think. The latest version of the database is 23.8, released just a few days ago. I'm going to go with this one for now. So, of course, I have dependencies for a Spring Boot, a Spring Data, Spring Test, Testcontainers, and then I'm making use of this version of the driver, 11 instead of 8. I think that probably could use 17, but I'm going to stick with 11. Then there is DbUnit. This is the latest version. And I'm also using Database Rider. And in order for this to work, then, of course, we had to use JUnit 5. So that's why we bring the JUnit Jupyter engine and the Oracle free Testcontainers module, because we're going to provision a database every time that we're going to run the test cases. All right. So the first one, let me show you using database unit, and this is the one that we have to be quite verbose in order to run this, to configure this particular test case. The first thing that we notice that the test case is annotated with Spring Boot test case, the Spring Boot test annotation, so this is quite normal. Then we have this Oracle container which explicitly configure with this version of the Oracle images coming from Gerald. Then manually, we will start that container before every test method, and we will shut down the container after all the test methods have been executed. But because we're also starting this container every time, and that generates a pristine environment, we need to tell the dependency injection container what is the URL that we can connect to, what is the username and password, and any of the properties. So we're using the old way, which is dynamic property source, to grab values from the container and insert those values into the dependency injection container. The next thing we're going to do is inject the repository and have access to the data source. This is the one that is available now because we have configured those dynamic properties. But then Here's something very specific with DbUnit and Oracle database. This version of DbUnit does not understand the Oracle dialect directly. So we have to do this, create some extension of one of those base testers which allow you to connect to the database in different ways using JDBC or data source or JNDI. In this case, we're using the data source database tester. And the only thing that we have to do is this. We're creating that subclass just to set one property. That's the only reason why we're doing that. And is this database tester the one that will allow you to seed the data before all the test cases and to verify the data after we run the test cases? And we're using some XML codes. There is some, XML files that allows you to define the data set. So for example, the customers, the input customers looks like this. Simple XML where the name of this element matches the table and the names of the attributes match the columns. So far, so good. What happens if I were to have a property where I need to do this? Will this work? Anyone here remember how XML works, or have you all migrated to JSON and YAML? Well, this is invalid XML. This is going to fail. So that DbUnit supports another extended XML format where instead of using attribute names, you could do this. You say customer. Obviously, that's not going to work. And there's another typo. And then I can say first name, like this. And our good friend, see data. And then this is where I can put whatever I want. So that will work out. Okay, so this is just an example. So we stay with this one. So we're going to read this XML file. This will be the basic data that is going to be sent out into our customer table. Where is our customer table? Here is the schema that matches the entity that we have defined. So far, so good. All right. So what is our test case doing? Let's look at that. DbUnit will insert the customer data set that we saw just before this test method is executed. And then we're going to grab or list the customers that match this particular query. So if we look at our data set, we have 2 entries with that value. So we should get how many elements here? 2. That's exactly what we're checking here. This test case, the only thing it's doing is some sort of sanity check against Spring Data. Is the list functionality of Spring Data implemented correctly or not, given my current settings? That's the only thing that this test case is checking. But the next one is, let's create a new entity, save it through the repository, so we're doing an insertion. And now, notice what we're doing. Now we're being more explicit. We load another data set that is external. Then we load a data set from the current database. And then we do a comparison of the two. We do a diff. And if this is successful, then the test case will be green. That means that we were successfully able to insert. Where is this data set? Is customers added XML, which is just 3 rows that contain the data that we inserted. So let's see that in action. Let's run this. And I'm going to make this bigger. There is Testcontainers running. And we have our 2 test cases green. Yay. Do you trust me? Trust but verify. Never trust a test case you have not seen fail at least once. Which means, let's break this test case. We expect 2 customers. What about 3? We insert a customer that says Joe Cool. Let's say something, no, this is not J Cool. This is JCON. All right? So what should happen now? 2 broken test cases. Here we go. There's our Spring test case running. And boom, boom. Failure, which in this case is success because that's what we're expecting. Yay. So this proves that we can initialize a database using test containers, and we can set up the state with DbUnit and validate the state afterwards. But do you really want to write all this code? No. Thank you very much. This is the reason why we're going to switch to Database Rider. So in Database Rider, we have two additional annotations. Here, DB Rider, and another annotation called Testcontainers. Now, so obviously we could have used Testcontainers with DbUnit, but I want to condense this even more. So now we have a container annotation for our Oracle container here, and no longer do we have to manually start and stop the container. This is going to happen automatically thanks to these two annotations. Good. We're still using the dynamic property source because somehow we need to tell the injection container about the Oracle properties, but there will be a way to solve this. And there is no tester. There is no subclass that has to be made in order to understand the Oracle dialect. Database Rider knows this because Database Rider is more modern. Also, notice that for every test method here, we're telling it, I want you to use this input dataset, which is going to be inserted in the database before, and I want you to use this expected dataset afterwards. So in the case of a simple finder, which will just query in the database, we're not supposed to do any mutations to the data. The input and the output dataset are the same. And then for the case that we want to insert a new customer, we are not doing explicit validation. We just need to say this is the input dataset and the output dataset, and we're done. All right? So let's run this, and let's see if that's actually true. You will see now Database Rider will output more metadata about our data source. So like this, in case that you want to validate some stuff. And turns out that this is correct. Perfect. Oh, let's make it fail. And I want to showcase another nice thing about DbUnit and Database Rider. So let's run this. In the case of the diff. So I changed the name of the value of one of the expected columns. So this second test case should fail, correct? And let's make this bigger. And we get the typical JUnit assertion that we expected one value versus the other. But also notice in the table customer, the first row for the column last name, we had one expectation, but we have something else. So that is way much better than just getting this simple thing right from plain JUnit, isn't it? More and more useful. All right. There is one more thing that I want to showcase, which is, can we get rid of that dynamic property source? Yes, we can. There is an annotation that was added, let me say, Spring Boot 310, I think, called Service Connection. It works for most of the relational database containers that Oracle, the Spring Boot and Testcontainers support. It does not work for all kind of containers. So with this, we only need to annotate the container, again, pass it the image that I want to use, and long gone is the explicit need of dynamic property source. Automatically, all those properties that may be required from the Testcontainers container will be supplied to the dependency injection container. The rest of the code is pretty much the same. So there's a repository, there's the input and the output datasets. Oh, by the way, did you notice something about the name of the dataset? It's not XML, it's YAML. So if you don't want to use XML, you can use YAML. So here is the input dataset. It's 2 rows where the key values are matching the key matches the name of the column, and the value will be the value for that given column. And the customers added looks like this. It's just 3 rows. All right. So let's run the second Database Rider test case, which should be green. And then we can make it fail. So there we go. Bigger. And this should be green shortly. Perfect. So to ensure that these things are doing what it's supposed to do, we can change this to 3. And we can say that the output dataset is the same as the input dataset, which is erroneous because we are inserting a new customer. So now we should have 2 failures. And this takes a moment. So the first one fails because the size is different here. And the second one fails because, well, the size of the insertion is different, obviously. We're expecting 2 given the data set, but we actually got 3 coming from the database. Cool. All right. So obviously, what I'm showcasing is a very trivial example. You may be saying, Andres, this is nothing close to my production data. I have hundreds of tables with millions of columns. Do you expect me to write these things by hand? No, I don't. What I expect you is to use these tools. There is a way for DbUnit that allows you to connect to the database and extract a data set. You can say, I want these tables with these columns, and export that into the short XML format or the long XML format. And once you have these exported resources, then you can manually modify things to your liking. So you don't have to start from scratch. And once you have those external resources, then you can run as many test cases as you want to. There's another thing that can happen is that besides and not only using external resources, you can create instances of the data set. So now let's go back into DbUnit. You can create instances of or subclasses of this, or actually implementations of this interface that can be a combination of, it need to be, of external resources and programmatic values. Anyone here knows a library called DataFaker? Allows you to generate fake data following certain formats. So do you need to generate a valid credit card number, at least that follows the format, or a valid telephone number, or an address, or a mailing, or an email, something like that? This is where DataFaker comes in. But obviously, the moment that we externalize these values into a resource, they are fixed. There will be times where we need dynamic data for timestamps, perhaps, or UIDs, or some sensitive data that for some reason you don't want to put into an external resource. So you can use DataFaker or other libraries that can do this kind of auto-generation of values, and you can weave these values with external resources or build everything in memory, supply that to an implementation of the iDataset interface, and then that will be your data that will be supplied to initialize the database and also to verify your test cases later. So what I'm showcasing is not I'm not just saying just use external resources so you can combine things. This is the easiest way, the quickest way to get started, but obviously you can do more with these libraries. Okay, let's go back to the slides. So what it's about coming on the future. There are more features coming up in Database Rider than I'm aware of. I know for a fact that it has a hard dependency with Kotlin. I am one of those people that don't like to use Kotlin as a dependency because it doesn't give me any value. Because I mean, it's just there in the background. It's just dead weight for me. So the maker of Database Rider will split the implementation of the library into smaller modules. So if you want to use the other capabilities, certainly do so. If you want to use the basics, then you can use a smaller module. In the case of Oracle specifically, there will be additional versions of the images that you can use with Testcontainers and Docker. But for those of you that for some reason cannot use Testcontainers, but would still would like to talk to or connect to an Oracle database, well, what about using them on CI, on CD? There's GitLab, there's Jenkins, there's GitHub, there's so many other options. These probably could be the most popular ones. So for now, if you happen to use GitHub Actions, there is a GitHub action out there that allows you to set up an Oracle database very, very easily, following all the defaults and sensible defaults, as a matter of fact. So you can do this in GitHub without any issues. You can create any containers. It's called services. You just have to write a lot of YAML code in order for this to work, and then you have to duplicate that for any workflows that you want to run, or you can do this in a reusable workflow. We can talk about many things about how to work on GitHub CI, GitHub Actions, but we have simplified things by providing a given action. So in the future, one of the things that we would like to do is also provide similar capabilities for Jenkins and for GitLab CI if you happen to also use those services. So my name is Almiray. I'm a Senior Principal Product Manager at Oracle. I guess you kind of got a grip for that. I am an open source developer. I really love talking about open source. One of my first early contributions to open source was to DbUnit. I'm the creator of the iDatabase test interface and its base implementations. So I'm a DbUnit contributor. I'm a Testcontainers champion. I'm a Java champion alumni. You can find me online as A. Almiray pretty much on all socials. I don't use Twitter anymore, so don't talk to me over there. But Mastodon, Blue Sky, or the others should not be any issues. So with this, I hope that I was able to show something new to you, that you were able to take something new as a learning lessons. For those of you that raised your hand that you didn't know what Testcontainers is, I hope that I show you the possibilities. There's more to it, but this is just the basics. So definitely give it a try. And I have a few resources for you. There's testcontainers.com where you can find information about the modules and other things that you can do with test containers. They have in the Slack community. They're quite active there. There's the link for DbUnit, which is still hosted on SourceForge. You can tell that it's a very old project. And Database Rider is hosted on GitHub. That's usually much modern. And in the case of Oracle Technologies, the first link is where you can sign up for the free version of the Oracle Cloud Services. It's always free. We will never charge your credit card, as opposed to other vendors, how they do things. The second one is for the version of the database on the cloud, the autonomous database. It can do a lot of things, like automatically creating indexes for you and do automatic updates. There are so many things that the database can do for you, and so you can concentrate on just doing what you need, which is creating solutions and not just handling the software. The third one is the link to the one that you can download on premises. This is the free version. And the fourth one is for a series of tutorials and online workshops that you can run with not just the Oracle database or the Oracle Cloud, but also Spring Boot, Micronaut, and other technologies that are somehow related to Oracle as well. All right. So we have a few minutes for questions. Let's see if there's anything else later. Oh, yeah. There's something out there. Dismiss. Is the container reinitialized after each test case? Yes. That is the whole point of test containers. You always get a pristine environment. So for that, make sure that whatever software you want to put in a container, it starts fast. Otherwise, your test cases will be a bit slow. What about partial assertion where the ID changes or insertion? One, you can use things like a data faker to inject the values that need to be generated, but also DbUnit allows you to filter columns in the data sets. So if there are some columns that have sensitive data or stuff that you know is not going to match all the time, like timestamps or dates, then you can also filter them out. Instead of using data faker, it's possible to extract the defined data sample from the database to work with. Yes, you can. Again, DbUnit provides the capabilities to connect to any data source as long as you have the right properties, and then grab one, two, or as many tables and one or as many columns from each one of these tables, and then extract that as an external resource. And can I merge several source XMLs and YAMLs to separate data? Yes, you can, because all is based on the given implementation of the iDataset. So you can grab a data set from external resources, another data set from programmatic APIs, and combine them into a composite data set. And you can do this with as many as needed. Any particular reason why my manager published those images in the name and not under Oracle? Because we wanted this to be fast, and there's a little bit of bureaucracy that we had to go through because everything is branded. I mean, it does make sense, right? So these images were published for the first time, I think, close to 6 years ago. We keep pushing that, and there's still a bit of bureaucracy and red tape that needs to be solved before we can push most, or if not all, of the benefits that you find in the GitHub hosted images into the official images. And this question about is using reuse true a good idea? Reuse in which sense? Which particular API are we talking about? Can I run test containers in Kubernetes? I think so. I am not one of those that use Kubernetes, so I really not that good at that. So take my answer with a grain of salt. Okay. So I think we're pretty much on time. So I thank you very much, and I hope that you continue to enjoy JCON. Cheers.